Today we'll talk about 9-point circle of a triangle. So the standard notation DEF PQR A prime B prime C prime lie on a circle which is called the 9-point circle. PQR are the midpoints of AH, BH and CH respectively. So the circle with PA prime as a diameter, because PDA prime is 90 degrees, the circle with PA prime as a diameter will pass through D. If we prove that angle PB prime A prime is also 90 degrees, then B prime will also lie on that circle. So A prime B prime is parallel to AB. So this angle is angle A, and P is the midpoint of AH and B prime is the midpoint of AC. So PB prime is parallel to CH. So angle AB prime P is equal to angle ACH, and ACH, this is 90 degrees, so this is pi by 2 minus A, and this was A, so this is also pi by 2 minus A. So this angle is 90 degrees. So B prime lies on the circle PDA prime. Similarly, C prime lies on the circle PDA prime. So if you consider the circle Q, which is the midpoint of BH, E and B prime, E is the foot of the altitude from B to AC. So just like this way, A prime and C prime lies on the circle, and similarly A prime and B prime lies on this circle. So all these circles are actually same because this is circumcircle of A prime, B prime, C prime. So we have shown that P, Q, R and D, E, F lies on the circumcircle of A prime, B prime, C prime, and this is a 9-point circle. So now we'll talk about the radius of the 9-point circle. So circumcircle of A prime, B prime, C prime will have the radius half as the circumcircle of ABC. Is an easy exercise. You can use this formula. The respective sides will be half of A, B and C, and the angles are also same. This angle is equal to, so this can be shown that radius of the 9-point circle is R by 2. This angle is this angle, this angle is this angle. And this angle is this angle. So this angle is this angle. So now we'll locate the center of the 9-point, the center of the 9-point circle. So consider this diagram. The triangle PNH and triangle A prime NO. N is the intersection point of A prime P and OH. So PH, we already know that AH is twice of OA prime. So PH is half of AH. So PH is equal to OA prime. So these two sides are same. These are vertically opposite angles. And angle OA prime N is equal to angle OAP. Why? Because AP AO prime, O is a parallelogram. I think we've already shown this earlier. OA prime is perpendicular and AH is perpendicular to BC, so they are parallel and opposite sides are same. AP is equal to OA prime. So AP A prime O is a parallelogram. That's all. And this angle OAP is equal to angle NPH. So triangle PNH is congruent to triangle A prime NO, and apply the N is a midpoint. So as a result of this, we can say that N belongs to OH. H and O are collinear, where N is the center of the 9-point circle, not as the intersection of these two lines A prime P and OH, but as the center of the 9-point circle lies on the OH. So another important point which lies on this line is the centroid. So if we consider this triangle, this diagram, so angle A, suppose this is G prime. Triangle AH G prime and triangle A prime OG are similar with a scale factor of 2:1, because AH is twice of OA prime and AH is parallel to OA prime. So AG prime upon G prime, A prime is 2, and we know that the centroid divides the median. A prime is the median, and we know that the centroid divides the median in this ratio 2:1. So G prime is actually the centroid. So G also lies on OH, and therefore OG and H are collinear. This line is a very special line for a triangle, and it's called the Euler line of a circle, Euler line of a triangle. It's called the Euler line of a triangle. So we'll see more properties of this later. One important theorem is this one, which is by Victor Thébault. The Euler lines, so D, E, F are the feet of altitudes. So Euler lines of triangles AFE, BD, F, and CED, they are all concurrent. So we'll prove this using geometric inversion in a circle later on. Thanks for watching.